Hey there, thanks for listening in and welcome to another podcast in a one-on-one setting. Here we dive into the stories of new technologies transforming and empowering the geospatial industry, and we learn more about the founders behind them. And in today's spotlight, we have Aistech Space. My name is Rosalie van der Maas, and I'm one of the co-founders of Ellipsis Drive, and here with me is our guest, David Paredes. David, thank you for joining. Can I ask you to tell us more about who you are and your joining with Aistech so far?
Thank you, Rosalie. It's a pleasure talking to you today. My name, as you said, it's David Paredes. I'm Chief Scientific Officer at Aistech Space. And I've been with the company since 2017, currently one of the oldest employees. Started as an engineer here and then passed through different places from ground segment to applications, and now supporting more research and development in general. Even though I was originally a physicist, I'm kind of acting as an engineer now.
Yeah, we see that more often. Our CTO has also started out as a theoretical physicist, and now he's definitely more of an engineer.
Yeah.
Cool. Yeah, so Aistech Space is in the business of generating thermal data. And when I say not all thermal data is equal, could you elaborate on that statement and explain how, what Aistech brings to the space is unique?
Yes. So thermal data, you can see thermal data like in Landsat pictures, MODIS pictures, and sometimes people talk about thermal as in everything thermal is the same, and we are actually in a very interesting space where there's many different bands and many different geometric and temporal resolutions, and each of these combinations of bands and resolutions can be used for different things. Like, for example, in the visible, you get the different spatial resolutions, like super high resolution that can be used for photo interpretation, or low resolution that you can use for more strategic analysis of what's going on. In thermal, you get like super high resolution, things like all the companies are trying to go sub 10 meters or even sub meter. That is a very difficult place to get at, and that's maybe very useful for the military defense, etc. Then you get the tens of meters, which seems to be like the right spot for applications like agriculture and forestry, etc. And then you have hundreds of meters or thousands of meters, and then you can do more towards climatic or big picture of what's going on. And then, so this is just one bit, the spatial aspect to it. And then you get the temporal, like, for example, if you look at the temperature, the surface temperature, this is what thermal Earth observation says to look at. Typically is the land surface temperature or the emissivity, or the kind of an indication of the materials that are forming the land. If you look at the temperature around the middle of the day, that tells you a lot about the stress, the water stress of the plants. And that's very useful, for example, for agriculture. Whereas, for example, if you're interested in wildfires, which, hot stuff, so it's good using thermal. It's better, for example, if you use a something like a 4 p.m. Overpass. So even if you had the same sensor, if you are observing the Earth at 10 p.m. or 12 or at 4 p.m., they may be able to tackle very different things. And depending on what combination of geometric, spectral combination, then you will be able to provide or cater for different industries. There is in that sense, Aistech, what we're aiming to do is to provide what we call high resolution. It's not real high resolution, but is better than Landsat. We're talking about targeting the 50-meter range resolution. We want to be able to provide thermal data every 6 hours anywhere on Earth. And we'll do that with a constellation of satellites. And we believe that because we'll be able to provide every 6 hours, then we'll be able to map the diurnal cycle, and that may be useful for for many different applications, from agriculture to forestry and others.
Okay, so you're saying your sweet spot within sort of the spectrum of 1 meter resolution or sub for military purposes and 100-meter resolution for like longer term climatic purposes. You sit like somewhere in the middle of that spectrum and aim to go for the agriculture and forestry use cases primarily.
Yes, more or less.
Yes.
Yeah,
Is
that would
it
be correct?
okay?
I mentioned agriculture in general, but I would say that water management, more generally speaking, would be what we are aiming to, because water management is very important for agriculture, but also for other industries like engineering or mining. They are like, water is one of our most valuable resources, and being
So I've been told, yeah.
water, yeah, that's what people say. Maybe it's what the next big war will be about. And this is important because we live in a world where resources, like, we are globalized, right? And resources are shared. And since water is one of these resources that we sometimes see litigation about, it's important to have like an independent source of information that tell you about this resource and that you can use to mediate and to reduce conflict.
Yeah, so related to that, I know in your communications to the market, Aistech speaks about improving life on Earth through the venture. If I ask you to narrow down on like some key industries or applications or use cases that you're involved with that are directly contributing to this, yeah, what sort of examples would you name?
Yes, I would say that the first example from our experience, but also in terms of the conception of the mission, would be wildfire management in general, and the pre and post wildfire in particular. Due to our changing environment, models that may have worked well to predict wildfires in the past might not be enough or sufficiently economically viable to continue moving forward. So what we are opting in is to provide data to different stakeholders so that they can monitor and update their understanding of wildfire danger in their territory. During a fire, while we're not focused on detection, because that would require us having many more satellites going around the Earth all the time, like sub 15-minute per visit time. While a wildfire is happening, teams need information about where the wildfire is and potentially where the wildfire will be moving. And using high resolution and high frequency thermal infrared will help them make decisions about the resources, and that may save lives. And then, of course, after wildfire, you need to understand what is the best course of action to take, whether you want cattle to pass through it to help, compact the soil, or to take any remaining vegetation or whatever. The right action depends on which status the soil is in and what is for example, the wildfire intensity that the forest fire burned at. So we are aiming to provide this contextual information for wildfire management and operational teams. So this is one set of applications. And as I mentioned beforehand, the other kind of big thing would be water management. Because even if thermal infrared data by itself may not be enough to close the water and energy balance equations, that is to have the complete information about the hydrological cycle, it can provide very useful and very granular data about what's happening at the surface. And you can input that and other observations into models to get a more accurate view about what's going on with the water in your territory. That, as I mentioned before, that has many uses. From agriculture, where up to 30% of the water that is used is wasted, to civil engineering, where you may want to be more optimal in understanding the properties of the terrain that you are trying to build something in, to geology. And in some territories where like mines may be using a lot of water because it has a big economic return, but then you need to balance that with the needs of farmers, that they may require this water to bring food to the people living in that territory. So what we're bringing to the table are tools so that this information gap between controllers of information and those affected by the policies or by the actions, so that they can be more equally, so that the field is equalized, and then we can resolve conflicts in an easier way.
That is I haven't thought about it that way yet. That indeed, by providing information on this from space, you can act as an equalizer when it comes to control of information. But only when that information is affordable and accessible for groups beyond, I'd say, the rich and highly technical. Is that something that your team has already thought about? How to make sure that it becomes mainstream?
That is a very nice question, because we're continually discussing this within our team and with other stakeholders. Like we see geospatial information as being, in general, quite expensive, and in general quite difficult to use for those that are not experts. Strategically speaking, we're moving towards making our information more accessible, both from the economic point of view and also from the usability point of view. Of course, the usability point of view ties very well into your kind of business, right? Where you make information from companies like us more accessible to users of that data, and also to providers of that data to give access to the data to the users. So this is one thing. This is about, I would say this is the cognitive barrier to use this information.
A nice way of putting it.
To the technological barrier to use this information. Of course, the ideal would be, okay, I am a farmer and I want to understand whether I need to water my plants. So I just want a map of, this is my plant, I need to water this one more than this other one, right? But there is a lot of downstream industry that needs to be developed. Now, the problem is that many of these technologies and companies that provide this do not have the right data to do that. So some of them use sensors on the ground. They have really good results, but they are just punctual sensors. So what we are aiming to do is to provide them with an extensive view so that they can develop their products. And we are partnering with several of them to try and contribute to that, to the ease of use and the applications for the end users. And I'll tackle another one of your points. And we are internally thinking about the best way to frame and to monetize this data service in a way that is very affordable to the people. And then we want to make it extra affordable to people trying to build stuff on top of it. So we're even considering, it's still not set in stone, and I hope that no one is listening, because it's not going to be very public, right? So we're even thinking about putting some form of open licensing to the data, and make it very, very economic, so that it can be as widely used as possible. Because in the end, what is data if people don't use it? And again, as we were saying, if we want this information to be an equalizer, it needs to be affordable.
Well, if you manage to crack that nut and this works out for you, it would be extraordinary. Because I think indeed,
get into ways of doing.
Yeah, because indeed, like breaking through that barrier of, indeed, like the technical and cognitive barrier is a key one, but the economic barrier cannot be ignored. Like you need both, without a doubt. And I imagine that like international organizations are supportive of this mission of yours. Do you experience active support, or just mostly lip service from organizations that can indeed see this as being very impactful for a very broad community?
So I would say that there is always mixed feelings. In general, I would say that whenever we talk to international organizations, they seem to be very interested in what we do. On one hand side, for example, ESA, like the European Space Agency, has been super supportive by considering us to be sufficiently disruptive and interesting to be part of the Copernicus contributing missions.
Which is a huge deal.
Which is a huge deal for us, and I thank them very much, and I congratulate the rest of the companies that were awarded these contracts, and which are very useful for a small company like us. It gives us the support, and it provides like some form of trust from the international community, saying, "Hey, this is interesting. Look at them." Right? For us, this is the most important thing. On the other side, we have international organizations that sometimes are very skeptical because of, I would say, the cognitive barrier and the market barrier, especially market-wise, like companies, big companies, etc. Sometimes they are reluctant, or they treat you with a little bit of respect because maybe they don't understand the business, and new space is a relatively new business, so it's difficult to understand it from the purely software or purely data point of view. Companies like ours require quite a bit of initial investment. So in terms of banking, etc., we need quite a lot of initial push in order to get there. But most of the organizations that we have spoken with, like forestry agencies or large agricultural producers, they seem to be very interested, especially if we can make the prices go down. It's always about, not always, but many times it's about the money.
Yeah, I mean, yeah, nothing else I can say about that. Yeah, I mean, I would love to have another conversation like this with you in a couple of years' time and see how, the plans that you're hatching to make this economical and to make this an equalizer, to see how that hatched out. Because I understand you can't share the secrets there, because it's in that sense also something that's worth protecting, at least in the early stages. But that definitely is piquing my interest. So one of the last questions I have for you is about additional data sources that you guys may be pushing or using to come to the best data services. Like you mentioned, that thermal infrared doesn't provide the complete picture for either these forest fires or wildfire use cases, as well as for water management use cases. Which data types would you consider to be your biggest sort of allies or value adders when you push this to an operational situation?
Yes, well, definitely meteorological information would be a big one, because it tells us first whether an acquisition from our satellites would be feasible. There will be low chance of clouds, for example. From that perspective also, there are several atmospheric components which greatly affect the quality of our end product. But then there's also layers that are interesting, especially in the visible. It tells you about the composition of the soil, so you can get a better understanding about the land surface temperature. And then going towards applications, other more general layers like settlement layers or understanding urban expansion, roads, etc. These can help you, for example, tell you about risks of different effects like wildfires. These are massively useful. In terms of other complementary data sets, big missions like the European Sentinels or Landsat, sensors like MODIS and VIRS, they always enable you to have a big picture and then tell you to focus your efforts on your high resolution satellites. They enable you to task better, to be more cost effective with your efforts, because in the end we're we are selling the data, but we're not selling the data. What we are selling is the data that you need when you need it. Data itself, right? Because we cannot, as a company, we cannot provide what everyone wants all the time. We are providing what some people need that are paying for that when they need it, and we are not looking at somewhere else, right? This is the value that we're providing as a company. And some of these other sensors also help us in that.
And so is your team leveraging these other sensors and data sources to indeed improve that value yourself, or is that something that you consider to also be the task of your potential users or those that choose to build on top of your service?
I would say that that is, we are definitely doing that. And we do that to maximize the value that we can potentially generate before selling the images.
I think that your potential user base would thank you for it, because it sounded complicated.
Yes. But once, probably users of our data or even downstream companies from our company would benefit from using these other sensors as well, and having not only access to that data, but also having an easy way to deal with it and extract information from that data would be super valuable for them, because we don't have a magic ball. So we can only go so far as to implying what are the best images. Our users will tell us, we want this. But many times our users not only want that, and what they want and what they need are different things. So we're trying to go a little step forward and trying to go a little beyond what they want, what they need. But they can also be helped by our own tools to do that themselves and be more proactive about what they observe.
Yeah, that's something I also very much recognize from our position at Ellipsis Drive, because you always know that using more data usually creates, well, two things. One, a more accurate picture of whatever you want to use, and two, a more complex data management situation. So on the one hand, it's good, and on the other hand, it also makes things complex. So indeed, trying to make it easy for people to draw on different data sources and really fuse that into the best insight that you can get is something that we also concern ourselves with, which would basically be your downstream. So yeah, I level with what you're seeing there very much.
And actually, so I have this notion that super high resolution imagery, or very high resolution imagery, it's being used mostly in a photo interpretation type of setting. And the reason, I have the feeling that the reason why it's so expensive is because not only that then you need a person looking at that, so you want to have the best details that you can, so that to ease their workload. But also the emissions are super expensive. But I do believe that if you can leverage lower resolution, we're not talking centimeters, but like tens of meters. If you can do that, but you can come to a point where a user doesn't need to look at your image, but rather get the insight directly. This would be the ideal situation. But it's tricky because there's right now, now since the 2010s, you have the Sentinels and the Landsat. So people there's a growing community of practice, but it's still not there yet. We're about to see that it's increasing in intensity and variety, the kind of things that you can do with these satellites. But because these satellites are not operational, they're not daily, they're not. Sometimes you do not have enough takes during the day, then people cannot get to that solution yet. But we expect with the introduction of us and other players, then we'll be able to bridge that gap, and the real exploitation of geospatial information will come to fruition.
Yeah, it just within this industry, you need to reach a certain scale, because otherwise you can't make the dream come true in that sense. Yeah. So my last question for you is, what's next for you guys? Like, what's the next major milestone that you're gunning for with the team at Aistech?
Everything that we're trying to do is the next big thing. But okay, so we expect to be launching our next generation thermal imager by the end of next year. That will bring us to being able to have more accurate land surface temperature estimations at Landsat type resolutions. Then we have on our pile of things to do, we are increasing the number of bands that we have. So we are aiming to have 3 or 4 bands in the thermal. And we may also be increasing the number of satellites as well, which may depend on funding. We are also increasing the intelligence of our satellite on board so that we can get better insights faster to our customers. And that combined with our bidirectional communications payload would certainly make a big leap towards usability of the data in an operational setting. And of course, we have ahead of us a Copernicus Contributing Missions contract, which would last 5 years, and hopefully by the end of that, we'll be qualified to being able to serve ESA, the European Space Agency, which is one of the hardest customers to please. If we can do them, we probably can do many other ones, apart from many other commercial contracts that we have lined up.
Great.
So
sounds good.
Very exciting times in the next few months and years.
Yeah, we'll keep a close eye out, and happy to support you guys in any way we're able to. With that, we are at time. So on behalf of our listeners, I want to thank you warmly for sharing your story today. And if you're tuning in and you'd like to know more about Aistech, make sure to visit their website and their socials. We'll leave some links in the description so you can go check them out. So thanks for being here with us today, and until the next one.
Bye-bye.